Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, I'll be going over 2021 AMC 10B number 20. This is one of the harder problems on the AMC set as well, as it is ranked pretty close to the end of the exam. So let's take a look at it. The figure is constructed from 11 line segments, each of length 2, so we can get that these are length 2, and that area of that, so basically it wants the area of the pentagon. And the area of the pentagon, we know that this, because all of these sides are 2, we know that this is a equilateral triangle, meaning that this is 60 degrees, this is 60 degrees, giving a total of 120 degrees. Now, the middle points are actually quite distracting us from what we actually want to do. Therefore, an ideal strategy after getting those 2 and 120 degrees would just to not see those line segments, and those are just designed to be distracting. So I will just remove them from our diagram. So let's see. Removing them from our diagram. I'll just rewrite that 120 degrees at the end. Let's see. So here's what we have over here, and clearly this is not a regular pentagon, so we cannot use any of the regular pentagon formulas. And that we know that this is this is 120 degrees, and we want to calculate the area. And we can certainly draw a line from A to C and A to B, separate this pentagon into 3 triangles so that it is easier to actually deal with and calculate the area of. And triangles are relatively better or easier to calculate than pentagons. And we know that this left triangle is congruent to this right triangle. Let's just try to calculate the length of AC, as we will need it later in this problem. So we can use law of cosine on the length of AC. So AC squared is equal to 2 squared plus 2 squared minus 2 times 2 times 2 cosine 120 degrees. We know that cosine 120 degrees would just be negative 1/2. So that would be 4 plus 4 minus, so negative 1/2, and this just cancels out with that, and that becomes plus, so plus 4. And that will be AC squared, and AC would just be square root of 12. We don't need to simplify this after all, and we'll see that later. And that if we calculate the area of triangle ABC, it will be 1/2 AB sine C, or you can use other formulas as well, but well, AB sine C is not actually what we have over here. It should be our length B, so AC sine B that we have over here. So 1/2 2 times 2 sine 120 degrees, which is root 3 over 2. So that will be 2 times root 3 over 2. And wait, 2 times root 3 and over 2 is already, let's see, 1/2 times AC sine B, so that will be 2 times root 3 over 2. That's right. So that will be square root of 3. And then the area of ACB, we know that this side length will be square root of 12 that we have over here, and that if we draw a height, we know that this will be 1, as it is isosceles triangle, and that would definitely be separated equally. And that the height, let's just call it h, so AH would just be square root of 12 minus 1 by the Pythagorean theorem to get square root of 11, and the area of ACD, which would be 2.5 times 2 times square root of 11, which is just square root of 11, and that the area of the whole pentagon would just be 2 times square root of 3 plus square root of 11, and it asks us to put it into this form where there's no coefficient. So let's multiply this 2 in to get square root of 12 plus square root of 11, and 12 plus 11 would get us to d23. So at the start of the video, I clearly told us to just erase all the line segments inside of the figure to make it more easier to see how our figure turns out to be solved in this way. And let's see if we erase that sounds weird, but if we put the line segments back, how distracting that would be. So according to our method, our line would be from A to C. However, notice here, many of you might think that this point is actually on the line segment AC, but that is actually not. Notice that is not. And there certainly exists a triangle of ACD, but there does not exist a triangle of ACD or a straight line from A to C passes through this point. And that also explains, even though this segment is 12, this segment is root 12, but this angle is not 30 degrees. Not 30 degrees. As you might expect here, this is obviously 30 degrees because this is 120 degrees, and this equilateral triangle is obviously 60 degrees, so we have the 30 degrees right here. But notice here we have, this is not on the same line segment, so there is a small angle over here. Let's see what we would get if we assumed it to be 30 degrees. We would get 1/2 times root 12 times root 12 times sine 30 degrees. And we know that sine 30 degrees would just be 1/2, and that would give us just 3, as opposed to the actual square root of 11, and that is not what we actually want. So that is it for 2021 AMC 10B number 20, and hopefully you will have a great day, and I will catch you in the next video.